Howdy, seventh grade. Today we are going to be talking about pizza because I love pizza and I'm sure y'all do, and we're going to talk about how to get the best deal on pizza next time you go to Pizza Hut or Domino's, wherever you get pizza. Either way, that's what we're going to be talking about. So we're going to do percent change today, but we're going to do percent change in multiple dimensions, which is going to make it a little bit different than normal. So my question is, if I've got two pizzas, and one of them is going to be 1.5 times bigger than the first. So this would be like a 10-inch pizza here and a 15-inch pizza here. I'm wondering, let me actually make this say 10 and 15. I'm wondering how much bigger my second pizza is than the first, because I don't eat pizzas just like straight across. I eat them as the whole area of the circle. So we know the size of the pizza would definitely be a circle here, so the size is based on the area. So first let's look at the percent change just of the radius. So if we start here and we end here, I can say that my percent change, if you remember this formula, awesome. If not, that's okay, we'll go over it again. My percent change is going to be the final minus the original divided by the original. And what that does, final minus original, is the change that happened, and if we divide it by the original, that'll make it a fraction for us. We have it like as a percentage of its original size, and that lets us compare things really easily. So this is going to give us percent change. So we start off with this 10-inch pizza, and we end up with a 15-inch pizza, and I want to know what the change is there. So my final would be 15 minus the original, which is 10, divided by 10, and 15 minus 10 would be 5 over 10. If I want a percent, I want to make it over 100, which would be 50 over 100. That would be 50%, just like that. So right now I'm thinking this second pizza right here, my second pizza, by the radius, is 50% bigger. But again, I don't eat a pizza going straight across the pizza. I eat the entire area of the pizza. So I don't think that radius is really how we should be measuring size of my pizza here. We should be doing with area. So I want to try this with area. And of course, to find area, we're going to do the area is equal to, that would be the circumference formula. It's going to be pi r squared. Pi times r squared. So for my first circle, my radius is 10. So my area of the small pizza is going to be equal to pi times 10 squared. And my area of my big pizza is going to equal pi times 15 squared. So I'm going to ask you again, which is bigger? Obviously the big one's bigger, but I want to know by how much. So if I do my formula again of the old minus the new divided by the new minus the old divided by the old, so the final minus original over original. If I use my original wording, it would probably work a little better. So the final would be pi times 15 squared. The original is pi times 10 squared. And we're going to divide by pi times 10 squared. So let's solve some of this. 15 squared is going to give me, let's see, 15 times 10 is 150, plus 75 is 225 times pi. I'm just going to leave it as times pi. You'll see why in a second. Minus 10 squared is 100 times pi divided by 100 pi. So going through this, we're going to look a little bit more at how this is going to work. So I end up with 225 pi minus 100 pi. And if we combine like terms, which I know we know how to do, we'd end up with 125 pi over 100 pi. A little bit of simplification. Pi cancels out with itself, so I end up with 125 over 100, which is 125%. So the area of a pizza that is 50% bigger is actually 125% bigger, which means that this second pizza, even though the radius is only 1.5 times the size, this one is actually 125% bigger. That's over twice the size. And most people, when they go into pizza places, don't quite recognize how much bigger a pizza you get just by increasing the radius by a little bit. So to get people to still buy bigger pizza, they have to make it kind of cheaper. So if you go to a pizza place, almost always the best option is to get the biggest pizza, especially if you're me and you just will eat the entire thing. So we're going to look at a couple more of these. It'll be a little bit easier with some squares and rectangles, because squares and rectangles make our lives easier. So if I have a towel that shrunk by 10% in the wash. So I have a towel and it shrunk by 10% when I washed it. I want to know what was the percent change in area. So if something shrunk by 10%, that means that it's going to be 90% its original size. So if it shrunk by 10%, that means that the final is minus the original divided by the original would be negative 10 over 100. Or we could say, after a lot of math with this, that the final is going to equal 0.9 times the original. And it's 0.9 because that is 90 out of 100, which is 100, or the whole minus 10%. So this is where the 0.9 comes from. So our side rather, is going to be 0.9 times the original. So if we want to find the final area, we're going to have to do that to both sides. So let's just pretend we have a towel here, and I'm going to make the sides be 100 by 100. I don't really know who has a towel that's can be measured in units that's 100 by 100, or a towel that's square, but we're going to go with it anyways. So if we have something that ends up with 90% of the side length, 90% of 100 would be 90, and 90% of 100 would be 90. So the final area here would be 100 times 100, which is 10,000. And the final area here would be 8,100. So if we look at the difference here, now we went from 10,000 to 8,100. So our total difference with percent change would be the final, which is 8,100, minus the original, which is 10,000, divided by the original 10,000. That's going to equal, if we do this subtraction on top, I end up with negative 1,900 over 10,000. And a very simple simplification gives me negative 19 over 100, which means we had a 19% decrease. So long as we get this over 100, that lets me end up with my percentage sign. And that's exactly what that means. We have a 19% decrease. So if your towel shrinks by 10%, you almost lose 20% of your towel, which sounds a little counterintuitive, but it's how dimensions work. They're kind of strange. That's okay. In any case, we've got 4 practice problems in the book. If y'all can check those out, that would be delightful. Have a wonderful day. I will see y'all in class.